So kind of a continuation. I started at a site like osboxes.org, and I got a VDI file. And so there are already pre-compiled images for my VirtualBox, or there's ones for VMware. There's a lot of sites out there. In fact, Microsoft even has a site you can go as a developer site, and you can get pre-compiled versions of Windows 10, 7, 8, 9, whatever's out there from Windows. Now, they have some license limitations in terms of how long they'll last, and you can't use them for production, but it's a great way to get the latest build from Microsoft even. They pre-compile them because they know that this idea of virtual isn't going to go away. The one I grabbed was Elementary OS. So Elementary OS, when we get it up and running here, hopefully, you'll see looks a lot like a Mac in a weird way. So we're going to take a look at it, and we're going to show you how you can take these VDIs and actually run them. So the first problem I have when I go look at this file that I downloaded, let me find it here real quick. So they're heavily, heavily compressed. So I put it in my Brad stuff folder. And you'll notice here it's heavily compressed, and the way it's compressed, Windows doesn't like. So it's 1.2 gigs compressed, and you'll see how big it's going to be when we expand it. But crap, Windows does a lot of really good things, but their ability to compress things is fairly lacking. So there is a great program I use for compressing files. And so my friend 7-Zip is a free program that you can use to encrypt and decrypt and compress files. So there's a lot of other ones. This just happens to be the one I've picked for ease of use. So I'm going to download the 64-bit version here. This file is really small to download. Notice it's already done. I'm going to give it permission to install. And it's going to say, where do I want to install it? I'm going to say yes. And that's really all it does. It runs very, very quickly. It's a short, small program that will allow us to deal with this. So here's the one problem we have with it. And what I've discovered is a lot of us don't know where files are stored at on our own computer. We're just used to storing things, and we have a list over here, and it says, oh, here's my documents, or here's something else. So for ease of use, I'm actually going to put this file really quickly. I'm going to take it from my documents, and I'm going to put it on the C drive at the base level, and I'll show you why here in just a second. So scroll down so I can see that, and I'm going to go, I'm just going to move its location here. Great. All right. The reason I did that is Windows doesn't always show you where these things are at, and if you're on a Mac, it's even worse. Macs kind of obfuscate unless you really realize where things are at. So the first thing I have to do is extract that, so I need to run my 7-Zip. So I run 7-Zip, and it looks like this. Well, where is, whoa, holy cow. All right, let me see if I can find it. So C Windows, well, it actually stores everything in a users, but we have a lot of users, so I'm not sure which one it is. So I just moved it onto the C drive here so we can find it. Just out of sheer ease of use. That wouldn't be what I would do normally, but, and then, I don't want to rename it. I can extract it up here. So I'm going to extract that. And I can put it anywhere I want to, but just for ease of use, I'm going to leave it right at that same directory. And I'm going to click OK. And it will take a few moments to extract. So this is highly dependent on the speed of your computer, how long it takes to do that. And it will create a VDI file out of this once it's done. And so we'll take a look really quickly. Come on, little guy. All right. So now it's created this file and it extracted it out, and so now there's material in there and all is well in the world. So that's a VDI file, and if I look at the properties, you'll see that size, it went from 1.2 gigs to almost 6 gigs in size. So programs like 7-Zip are much, much better at compressing that data down. It's literally a 4-to-1 compression. So now I have a much bigger file to work with, that VDI file, and I know where it's at. So I know it's just at the C: drive. So I'm going to fire up, I'm going to close this out so I don't have 12 things up and running. I'm going to fire up my friend VirtualBox. It should end up somewhere. Nah, I don't care that there's a new version, don't care. And we installed Ubuntu and we put some information in there. Well, we have, come back here a minute. We're going to do the same thing. So we're going to start a new one. We're going to go to our Blue Reese's. And I don't care where it's at. We're going to end up storing it. Except I want to call this one. We know it's going to be elementary. We know that it's not Windows. It's actually a form of Linux. We want 64-bit. Any of them should actually work. We're going to click Next. We're going to move this up a little bit. The hard drive is where we change something. And this is the difference. We're going to use an existing virtual hard drive file. And I have to go search for it. They've made it a little tougher because now I have to add that location into my directory. So I'm going to add. I'm going to go to this PC local drive, which is going to yell at me that I'm almost full. And I'm going to open up that VDI file right here. So I'm going to choose it, and so I've attached it. Now that it's actually plugged in there, I went through that little bit of trouble. I didn't have to install it. It's actually going to run so this first time through, it'll set some parameters, so it'll take a little bit longer. Now, here's the question. Where do I get a username and password? So we went back to the OS boxes, so you need to go back and look at what did they use for osboxes.org. Go back and find it, and it will tell you VirtualBox images, elementary, and it should actually tell you so it'll say under info it'll usually give you so username is osboxes, password is osboxes.org. So OS boxes. And we're up and running right now. So seeing that, you guys are probably like, well, man, why did we spend all class making us install that? Little easier way to do it, kind of handy. And so that's the easy way to grab these. We can do updates, we can do anything we want to do with it. We're up and running, and we have a virtual operating system. So a lot of times we'll build a library of things we want to use. So whether it's Windows images, whatever, we can take those VDI files. They're not stuck just on that one computer we created them on. I can throw them out on my NAS or even on a portable hard drive if I want to, and move it to another location. And I can run that same copy on something else. So it's really kind of a handy way to work. So this one's got a scroll. So I said it's a little like Mac, because a lot of your stuff is down here on the bottom and it has a very similar feel. This one does a lot of stuff, and they're free. So I encourage you to try them. Go to those VDI images and grab a couple if you have the hard drive space to do it. It's an interesting experiment. That's this idea of that virtual. So most of the time when we deploy a server, so the first time we may have to build it from scratch, but we don't have to do that every time we deploy a Windows 2016 server or 2019. And if we're going to do it inside that virtual experience, this is the way we start deploying those, is those images. And VMware images are a little different, but work nearly the same. So this takes its drive space, it takes its operating system, takes all that information with it, and it's portable. And that's one of the great advantages to this idea of virtual. So in most cases, the hardest part is downloading that VDI image and extracting it. If you're on a Mac or a Linux box, it's going to understand that encryption or that shrinking compression routine. Automatically, Windows, we have to put in a third piece in there, something like 7-zip. But it's up and it's running, and it literally probably took us, 7 minutes to do that whole thing? The download was longer than anything else. So, and you'll see this is a fully functioning operating system in here. So it's got different apps in it. Well, what's interesting then, I can also run this one at the same time. Now this computer is going to struggle a little bit because I don't have enough resources to do everything at once. But we can have multiple operating systems running at the same time. You're limited in some cases due to how much memory you have or how much processing power you have. But so now I'm a Type 2 hypervisor that's running on top of Windows 10, and now I'm running Ubuntu and Elementary OS both at the same time. And I could certainly run Windows 10 or something else if I'd installed it at the same time also. So it's just kind of an interesting way to show you what this virtual piece is. It makes more sense when you get to see it. So I encourage you to try this, run some different ones. So let me see if I can get logged in if I remember my password, which is luckily typed in there so I don't remember it, 2019. So there we actually have two of them at the same time running. So if I want to run, say I want to put up a calculator, well, this is loading, I can still run that. The other piece that's interesting, we talked about those settings. So your network setting is probably the most important one here. So right now it's set up as a NAT. I'm going to actually change that to a bridged. So it's going to see the direct network of my computer. So I'm going to restart that guy. I'm just going to do this and restart. So I'm restarting that virtual machine. Something went wrong, whatever. I'm going to power it on. And by changing that NAT, it actually goes out through my network card now. It's going to be joined into the same network. So this one's going to be on that .56 network. This one's now going to be on my internal network. And so if I had printers or anything else attached, I'd be able to utilize them. So have our terminal. No, it doesn't have that one in there. Sudo apt install. No. If I can spell. So, well, that one's starting up. I had to install it really quickly, and so in installing anything in Linux, you have to do you have to authenticate. So just like those UAC controls with Windows, but you can force it by using what's sudo, so you become the super operator, and so that's what I did. And so now you can see my network here. What's up and running, and I can see my IP address and everything using it's called ifconfig, not ipconfig. So it's a little different, but not a horrible bit. And so now we have, on this side, we have Ubuntu running in that side. So virtual machines are really, really interesting. I encourage you to try it. Spend some time, practice, play with it. This technology, this idea of virtualization, is going everywhere. And think about in here in the lab. We have contemplated this idea that is using a type 1 hypervisor. So everything is virtualized in this lab. So when you sit down at that computer, you have a list of options. You could run Ubuntu. You could run Elementary OS. You could run Windows 10. You could run Server. So, and of course, just like Windows, now even the updates are built in. So it's wanting to tell us that we need to update. So if I look at my computer and I pull up the task manager, you can see that it's probably a little taxed because I'm running 2 operating systems. So I'm using whatever's on this one. I think this one's only 8 gigs. I'm running 88% of the memory, and depending on what I do, you can see that CPU will spike pretty quickly. This computer is not really designed to do this kind of processing, but we'll try something here, and you'll see that CPU spike up pretty quickly. And so if I go out, got to do that real quick. So if I go out on the web on here, you'll start to see that CPU usage spike. So this is just an example of, and so you can see that delay, the little bit of lag, and part of that is because this hardware is not optimized for it. It's not, this computer here is, I don't know, 4 or 5 years old, not very, very fast, quite frankly. So we can actually do it, but you'll see it takes a hit and a little bit of a performance hit. So that's one of the downsides, is that performance hits. And if I were actually doing some work on these, you'd see that you come to your chunk. So you can save the machine state. I don't care that I do. That's like hitting the power button. And so now if I do this, and you'll see that utilization drop right off really, really quickly, because all of a sudden it's down. And the biggest app then seems to be our recording app. So I'm quite frankly amazed that it was able to run both of those and the recording app, which probably just crashed at the same time. So that's that power of virtualization. So try things, use it. I can do it on that server side, and that's where it becomes most important. But we want to avoid that single failure. So if you have somebody that says, man, we're going to virtualize all of our servers and put them on one box, you might want to stop and go, wait, you do have a backup physical machine, right? You have a second physical machine that you can move those to. So if I had been doing work in one of those and actually saved the machine state, it saves it in that VDI. When I closed it and I move it to another machine, it's going to open up at exactly the same point I'm at. So it's pretty handy. Now, VirtualBox can't do things like the vMotion. I have to shut it down, save it, and then move it. I can't move it on the fly. But again, VirtualBox is free, so it's kind of that case of you get, in some cases, what you pay for a little bit. All right, so I want slide chunk. So we went through encryption. We looked at remote access a little bit. So you guys had to do an assignment last week, and so we looked at, I showed you guys the one I prefer. Just if money were no object, there might be some other ones, but you see that technology a lot in terms of support for products and for computers. It's almost ubiquitous now that they have some form of support. You will see a lot of companies right online have a built-in link that says, oh, if I need help, click here. And it will actually open up a session, and you can actually install their software, whatever it happens to be, and you can see it. We do it all the time now inside of things like Zoom. You can actually use Zoom to see what somebody else is doing on the computer. We can use Collaborate inside of Blackboard. And it makes life a lot easier when you're trying to do advising with a student and you're trying to tell them you need to enroll in a class. Well, I will tell you one of the downsides to MyPSC is your experience as a student looks a lot different. And so sometimes when we had that frustration, this is a great way that we can actually see exactly what you're doing. And so there are literally hundreds of different types of remote access software. So you will see that we have other ways we can get in there. Virtual private networks is a term that you are seeing a lot. So when we have a VPN says this is how I can connect to offices, a computer to an office, two computers. In other words, we take all that traffic that goes between those locations and we make a tunnel out of it. That's really what we're doing. And we take all that data and we scramble it from one location to the other. So we used to do this on command line, called terminal emulation. We've gotten away from that. We don't have to type at the green screen or the black screen, although that worked really well when all we had to do was dial in. But now we've got these VPNs, and we can actually then set them up from an office to an office. So we don't have to have a completely different office. So if we do, which one is that? So we can actually set this up so that we have a connection to another office, and it's just like we are there. So if Peru suddenly built another center in Lincoln, we would use VPN software or a VPN connection at each end, and it would look like you were literally sitting there. So all your same things work. Your Active Directory logins, you'd be able to even print to, for example, the printer here on campus if you had that ability. So Telnet was one of the first ones, and that was a really good thing. It was terminal emulation, except Telnet had very little security. So they've come up with some other ones. So SSH, and the most common one is something called PuTTY. And so you may still see that if you're in, depending on how nerdy your company is, but we're trying to get away from these command line apps if we can. They're efficient, but they're not user friendly. And so we're trying to get away from them. So this one is probably the most common one. It is really a great way to make a connection. It's encrypted, but it's not necessarily user friendly. And we want everybody to be secure, so we need to come up with other ways. And so one of them we do inside of our networks mostly, although you can route it outside, is something called remote desktop. And so Windows came out with this idea, and from a Windows machine, it's great. I can remote desktop. It's quick, it's fast, it's fairly lightweight on network resources. And so on every Windows machine, if I hit the Windows button and I type remote, I get remote desktop connection. It pops up a window like this, and you can see I've already used this before because this is what I use a lot of times to get into the server. And apparently I can't remember what my password is. In either case, I have it somewhere. But that provides a really quick access in. So inside of my network, I use that a lot. There are ways we can port that out, but it's not as secure as a lot of other methods, and so I don't really encourage that. VNC is an open source model of a very similar tool. So you will see there's a lot of them built on something called VNC. a lot of even the commercial products are built using what's behind the scene is actually called VNC. So you'll see those two a lot. I prefer to use those internally. If I'm going to go external, I like to use some of the commercial products simply because I like to think I'm paying for that. Now, did they use some of the same technologies and just adapt it and modify it? Probably. But I'm buying that guarantee or a assurance that my traffic really is encrypted from end to end. So when I use something like Splashtop, I log in, I go, right there actually are encrypting all that traffic. So we hope that that's the case. So there's two different ways we can manage that. So out of band or in band. So out of band is outside of our normal traffic stream, so we're sending control pieces outside of that. In band means it's embedded into that control stream. So if you see those terms, that's what you're talking about there. So there's other things out there. We may want to look at how do we move files. And we do this in your web design class. We make you use FTP, File Transfer Protocol. Why do we do that? It's easy, and it's scary as crap. Because we're allowing an unencrypted connection. Yes, you have to have a password, it looks like. But when you send that password, you're sending that password unencrypted. Your data is unencrypted as you send it. It's not secure. So we've made secure ones. So we've got secure FTP in different kinds. There is also one called trivial FTP. Trivial FTP sounds weird. Why would I want something called trivial? Trivial means tiny, right? Or minuscule. We use that for things like managing switches. If we're updating, so a lot of like HP switches or Cisco equipment, networking equipment uses trivial FTP. It's secured, but it's designed for smaller packages. So we send a package to that router. The router doesn't have a lot of extra processing power, and it can deal with it that way. So there's not a graphical piece to trivial FTP. That's back at the good old command line. But it's secure versus FTP. We actually had, because we use FTP, the Bobcat web server we use, which is actually a virtualized server sitting over an admin, actually has been hacked before because it sets open. There are people that are looking for those open ports of FTP and want to take it over. And what they're trying to do is, in the case of what we had happen, was they injected a whole bunch of code into everybody's website that was on there. So it became a spam site for them. So we wanted to make the site easy so you understand FTP, not deal with all the security protocols, and quite frankly, what we had was a little bit of difficulty getting the security to negotiate through our firewalls back in. So we chose, hey, let's just do FTP. Not necessarily the best choice, but they're non-critical data. It was monitored pretty frequently, and what we did was just flushed it down the drain and started over again. So we utilized it. But when you see FTP still used for mission critical, it scares the crap out of me, quite frankly. So we talked about VPN as being a tunnel. So it is a connection between 2 points. So those points can be a site to site, in other words, one location to another, can be individual clients to a site, or it could be a host to host. So this is a model of some of that VPN. So in this case, we have a bunch of offices, and each one has a VPN gateway. It's built into a lot of firewalls you can actually build it into, or routers. It allows you to create that tunnel. So they go out over the internet, but your connection is actually a secured connection. It's encrypted. It tunnels. It forms a link between the two of them. So in this case, all these offices are able to interconnect, and they put a gateway in here. It makes sense, and it doesn't take a lot of hardware, honestly, to do that. So not too long ago, I worked with a radio station to set this up because they had bought some additional radio stations in small towns, and they wanted to set up a VPN. So all of those clients would feed back to their central office, and they could control the radio stations. The models we selected, honestly, I think we spent about $400 at each point to do that. And then at the head location, we spent about $2,000 on hardware. That was their budget. They didn't want to spend a lot more than that. There are better models to do it, but we made it work on that limited budget. But that's the same model. So the main radio station is connected then to all the affiliate radio stations, and so all the traffic, in other words, how they put pieces on the air, are all controlled from that centralized station, and they can see it directly. You're going to see that quite a bit. Now, in most cases, they're going to hire somebody specialized in that to set it up. It's not something that your IT staff does all the time, probably, but you see it more and more often. So, again, if Peru sets up a remote site, or you go to somewhere like Highland Community College, which has campuses all over, they would use VPN software. If you have a hospital and it's got clinics, remote clinics, they're going to use a VPN so they can see that. It's pretty common. Where you see it actually a little more commonly, and I'll show you here, like in healthcare, is actually the model more similar to here, where we have that VPN gateway at our hospital or branch office, and then people connect with a software client. So we have these telecommuters now. So I talked to a student who graduated a couple years ago last night, happened to walk outside and get the mail, and Dolores walked by, and she's working for a bank out of Omaha. She can work from home occasionally, and they use a VPN to connect back in, so that banking information is secure. In the case of some hospitals I've worked with, when the doctors want to access patient notes and records, A, for their own convenience, they're doing it at home, and B, to get stuff done and so they can actually get home, they may need to call in for, a patient they want to check on, see what's going on. Most of the cases, we put it on a laptop, for example, and we put on a software VPN here, and then we have a VPN at the hospital, and then they're making that tunneled connection that way. So there's mobile clients, there's ones for laptops, there's ones for about everything, and then we can also do the remote office. And there are some standards that we can interconnect from one company to another. Sort of. So there's some open VPN standards that are set. I will say it tends to work better if we are homogeneous in our network, at least in this regard. So if I'm going to have a Cisco VPN concentrator, I really need to use the Cisco clients, or at least it seems to work better. It removes some of that inability to function. So that is one way we can do it. Typically, we throw it on that router. Routers tend to be based on Unix of some sort. So what is a VPN concentrator? And so a VPN concentrator is really nothing more. It's designed to handle that traffic from all of those clients. So if we have a one-to-one connection, that's not a lot of load. But if I have 100 remote clients, that's a pretty significant amount of encryption and traffic going back and forth. And so we tend to use something called a VPN concentrator. If you're at that scale, the price isn't going to scare you, because you're going to start $5,000 on up for something like that. You can do it with other models, but you're probably around that. And where you actually set that in is your external firewall, and you have a router connects to the VPN. And I will say most instances we also have another firewall then between the network and that VPN. And sometimes we actually set it off to the side so it's got its own firewalls. What that gives us is the ability, if, oh crap, somebody's corrupted our network or something bad, I see out on the, a user hasn't done something right, I can pull the plug a little easier, so if it's off to the side. So this model is probably correct for all those other clients, but you'd think our external access to the internet is probably on another leg. So what it does is allows us to have, you're on a Wi-Fi cafe. We don't know where that traffic's going. It makes a tunnel from your computer to the office. It alleviates some of that issue. You can actually purchase a VPN connection for yourself. There are lots of sites that will allow you to purchase a VPN that tunnels your traffic back through them. Why would I want to do that? Well, I'm paranoid. I'm not sure about this connection at the hotel. I'm not sure about this connection at a cafe. I'm darn sure not sure about this just weird connection at this college I stopped at, right? You can purchase that service. It's usually $10 a month or something for a VPN. There's a couple of other interesting uses for it. If you're interested in TV shows that are only available in, for example, England, and you want to use Netflix, Netflix will say, well, no, you're in the US, you can't get that programming content that's there. You can actually use some of the VPNs to make it appear that you're actually in England or another country. So you can hide your traffic that way a little bit. You can hide your traffic that way from your own internet service provider. So if you're doing something a little shady, you could use one of these, not to advocate for that. But if you're going places that you maybe don't want, your local internet service provider, say on campus, to know where you're going, you could use one. And you'll see in business, we almost always use it. If you're traveling, if you're paranoid at all, if you've had my Cyber 360 class, you're already paranoid. Just from a little bit I've talked about in here, you should be a little paranoid. It's not a bad idea to do. Because I trust Wi-Fi about as much as I do as a hug from strangers at this point, right? Had to throw in a Corona joke in there. Had to go in there. So this would be a corporate network, but whether you're home, you're traveling, you go through that firewall. And most likely, even in this case, you're actually using a virtual interface. You're not getting that data downloaded to your computer to use it. You're manipulating that data inside of their network at some point. So we typically have all different kinds of connections. The testing that this book is modeled over is heavily Citrix-based, Cisco-centric. So Cisco is one of the preeminent network providers. So you'll see a lot of terms and things in here, and this is another example of that. So dynamic multipoint is a term that Cisco came up with, and they said, all right, well, we're going to create this tunneling system that just happens on the fly, and we don't have to. No. It's a Cisco product, and they're trying to market a little bit to you. So yes, Cisco can do VPNs very well, but there are also 100 other companies that can do a VPN also as well. We can actually do a VPN from the router we have in here, so if we wanted to. But again, you need to make sure you're aware of those conditions. It's not the most complicated thing you can do in networking, but you need to have a clear roadmap and some plans, and it's not one that you usually implement in a 5-minute period. You kind of have to draw it out and what you're doing. And there's some things you have to be aware of when you're doing these VPNs about your IP addresses and things. And we're not going to get into that level of detail, but so tunneling is that protocol. So again, we have another language or protocol that we're going to do it. Different protocols have different requirements, different encryption pieces. So you have to make sure that the encryption is the same on both types, that you're at the same type, and that you're a strong enough encryption. What it really does is this IP packet, it says, all right, we're going to put a new header and an IPsec header and all this other piece in there, and my original frame gets buried in there and scrambled so that we can't see that data in there unless we have those encryption keys. So the downside to VPNs is it adds some overhead. In other words, we're going to have a little more processing power is needed. We're going to have a little bit more lag because we have to unscramble and scramble data. But with current technology, so if you have a broadband connection, if you've got a decent newer, this is a 4 or 5-year-old computer and we can do it, it's worth the effort. And so if a company says, hey, I just want you to log into our system and we're not using a VPN, I would get paranoid really quickly. And I would start looking at them going, wait, you're doing what? Let me check with everybody what's going on. And so sometimes you'll run into these system admins who are paranoid and say, no, you can't do that, and these are the things why you can't do that. And a lot of times it really is that idea of security in there. So there's essentially point-to-point protocol is done. So no longer do we see it unless it's a legacy installation. In that case, it really needs to be updated, and it's that case of, hey, this has been running for about 7 years. Maybe we should check and see what we're doing. Nobody's done any updates. Probably time to look at it. So layer 2 tunneling protocol. So this is that idea, in theory, that we can mix different equipment vendors. Unless you're using something that's proprietary. So cough, cough, Cisco tries to put in some proprietary pieces. That's where we run into mixes. There's some other companies that have had some weird, I want to do some proprietary things, like Juniper Networks has done that before. So we need to make sure that we're using similar standards, similar configurations. So the most common thing we actually use, weirdly, is this idea of this OpenVPN. So if I'm going to do this on cheaper equipment, so my boss poo-pooed my idea for the $10,000 Cisco equipment for this month. I need to do this on a $300 piece of hardware. I can actually do it on using OpenVPN. I can get an OpenVPN client on my desktop, and I'm going to argue that the open piece makes it actually a little more secure because there's a lot more eyes on that code than there are if it's a closed system like Cisco. So Cisco, their engineers have seen the code. But if there's an exploit and they decide they don't have a fix for it right away and they don't fix it, it's going to take a little while longer. So OpenVPN is the piece you need to take out of that. You'll see that pretty commonly. So once you decide you're going to do that, then you have some other decisions to make. What kind of policies and requirements and devices? So we need to put those down in your company. And I know that's the hardest part of a lot of companies is writing those policies. So do you require them to have a strong password, or is 1234 a good enough password? I hope not. I hope not. We also need to make sure that if they're using company equipment, it's updated. If they're using their own equipment, that's where it gets a little sketchy in some cases. How do I monitor and maintain somebody else's equipment? Need to be aware of that. Things like password policies. So if you take 360, you're going to learn that I have a phrase called passwords are BS. But I'm also going to say it's one of the better things we have right now. If you don't have a password update policy and you're allowing people to use the same password for 2 years, you have a problem. Now, the flip side of that is if you're making them change it every 30 days, you probably have a problem because nobody's going to remember it. They're going to scribble it down. It's going to be on a sticky note. Anything that we're going to access with, we need to have encrypted. And that means those drives, those storage drives, encrypted at rest. Not just the traffic, but your drives need to be encrypted also. Just out of sheer paranoia. The more holes we poke into our company, even though we think we're doing it all right, there's thousands and thousands of entities and people out there poking their noses around. The more you're on the internet, the more your exposure is out there, the more holes you have, the more people are going to try to find their way in there. And we can search the internet pretty quickly and start looking for those holes. And if we know that there's a particular issue with a Cisco routing protocol, and I search that out and I find you have that port open, holy cow. You're probably done for. So those kinds of things are important. So data has to be secure. And some of it seems silly. Why do I care who's enrolled at Peru State College? Well, do you guys have financial aid data stored back in there also? And I have enough data about you that I can actually data mine you, and I can create an account, and I could set up a whole bunch of fake doctor's offices that start billing you for random things that we're billing insurance companies and Medicare from if we get your information. Oops. So it's not necessarily just using your credit card. There's some bigger pieces out there we can get more data out of you. In fact, what we find especially when we look at younger college-age students, what hackers are trying to get really is that medical data. They could care less about your credit cards. Because your credit cards are going to get them 20, 50, 100 bucks or something by the time they try to resale it and get out of that. Your medical data could be worth hundreds of thousands of dollars. And insurance companies sometimes pay things without blinking. So if all that's in there and it's accessible, and the more holes we've poked in there, now we need to make sure that those are all secure. So I used to really laugh a few years ago, more than a few, before Dr. Beardsley was at our campus. We had a systems admin / director, whatever they called him at that point, who was adamant that we didn't have Wi-Fi on campus because of the security holes. And I will argue Wi-Fi is scary as crap. But the same token, before my PSC, the only way we could get into our system on campus was using Telnet. Not a secured model, Telnet, where all of my stuff is sent clear text, including your student data records and everything else. It was not particularly secure. We didn't have a really good password policy on it even. It didn't have a lockout, so is statute of limitations passed? Probably. So to play with it one day, I did some experimentation. I tried to see if I could break into somebody's account. Not going to say who at that point, but they had a lot more administrative access to things than I did. And so I used a brute force program because it didn't lock me out. And I used a fairly common table and dictionary table because I knew that we had these rules of this is your characters, this is what you're supposed to have, and people are patterns of habit. So if I say you need 8 characters and one of them needs to be a capital letter and one needs to be a number and a letter, I can see where you're going to put that. It's going to be capital letter first, most people. And in fact, that's what they did. And it was unsecure. I could have also got it if he had Wi-Fi at their house and it was unsecured, and then grab that traffic and I could have got it that way. So it wasn't a secure place. So make sure that you do that. So my concerns were not immediately addressed, I will say that. But when something happened to the system while I was on vacation, I sure was accused of it, though. I will say that also. So if any of your users lose things, you have to have that in policy. You have to let them know that, hey, we're not going to fire you because your laptop got stolen, but you have to tell us immediately. And hopefully you've got some pieces in there, some mobile device management, where you can wipe their device remotely. And hopefully you've got it set up where they're not storing data on that device. But data gets stolen all the time, so you need to be careful. So there was a VA contractor a couple years ago, had a laptop get stolen. 26 million records for veterans stolen. Ooh. Ooh. So it's kind of that consistency, making sure you're secure on all fronts. Are you ever going to be 100% secure? No. But can you do steps to try to prevent it and mitigate the damage if it does happen? Yes. So what do we want to do? We want to encrypt everything. Any communications back and forth we want to encrypt. We need to remember, email typically not encrypted, not a safe way to send things like passwords. I know that seems silly, but sending that password over email is not typically a safe thing unless you're doing end-to-end encryption on your email. Most places aren't willing to pay for that. So you need to make sure when you connect these devices that you're secure. And there's some training involving people and how to do that. So one of the projects I've been involved with in the last couple of years was some mobile devices in police cars in a couple of different locations. So they need to be able to connect back into a centralized server so that they can send information, receive information, type reports, check your driver's license, all those kinds of things. And the worst part about this has been training those users and how and what not to do. What are stupid things to do, quite frankly. And so essentially what we had to do was lock down the laptops and tablets that they could do nothing unless they actually were going through the VPN service that we used. And we use a very specialized one in that. It was, I don't even want to, the cost on it was stunning. But it's designed and certified for law enforcement. And so it sets on a server and has an encrypted connection to it. And we can monitor and those laptops and control those laptops remotely. Do you think the laptop in a police car is a high theft target? Yeah, they think there might be something on there. Not really. It's all set on the server, which hopefully is protected enough. But getting all that data back and going through multiple different types of cell phone and other carriers has been challenging. And that connection needs to be encrypted from end to end. The FBI says, hey, make sure you do it. The State Patrol looks and checks and says, hey, make sure you do this. And so it's been a little challenging because some people are like, well, I can just get on my phone. And no. You can't just get on your phone and log in there. That's not going to work. We can't do that. And so it was kind of an eye-opening experience on that. How do we create that secure communications channel? And so hopefully we've done it. And hopefully we don't have any issues. But I'm going to guess if we don't continue to update and we don't look at it objectively, somebody's going to try to get into that. And so we actually have a very bizarre way we've got that set up in terms of behind firewalls. It's not just one firewall. It's not just one vendor. And so getting that tunneling protocol routed through them all has been a little challenging also. But we want to make sure that data is protected because that has access to a lot of ramifications. So even the fact of one of the counties actually had their email hacked, essentially. So they were using a contracted IT service person who decided he could make money by selling off email to some of the local drug dealers. So they'd know when the drug raids are going. Yikes. So it does happen. And that's within 100 miles of here that happened. So you do need to be aware. Those remote connection pieces are important. That policies are important. If you have to tell Jim or Mary or Bob or whoever 22 times that you can't do this on an unencrypted connection, you probably need to think about the ramifications. And that's where those policies will then lead to the HR piece. So it happens. We know that it's going to happen. So the latest one that I had that was particularly frightening was they needed to send data to a district attorney, and they had contacted me and said, hey, I just set up one of those free drop boxes for my evidence and sent it to the county attorney. Wait, you did what? So you do have to be aware. Where is that data stored? Where is it living? And people now, one of the issues is people want to get stuff done, and there's all these web apps that we can do stuff, but is it safe? And I'm going to say Dropbox, storing your evidence, is probably not a safe place for that to live, quite frankly. And certainly not confidential. It doesn't meet all the requirements. So, all right. So this week, on your assignments, you should have, if I get back to the right spot, there's a couple of pieces. I took out a lab because I had enough people not able to get into it that I said, we're just going to eliminate it. And I think I might go through and eliminate most of those. So Hyper-V you don't have to do. You are welcome to try it. You can get to it from inside of Cengage, but it seemed like we had a lot of people not able to get into that from some feedback I got. So there is a quiz and there's a couple of lab simulations, so make sure you do those. The other thing I am going to do, and I'll send out an announcement on there, is I am going to manually push over data from Cengage and insert it into Blackboard. So probably like weeks 1 through 6. So if you're missing some of those Cengage assignments or lab connections or anything, make sure you go in and do it, because I really don't want to move data over more than once because it's a pain in the butt and I'm lazy. So I'll send out an announcement, so just go double check and make sure it's all over there. I wish we could figure out a way to connect it better, but my only suggestion from Cengage that's been actually relevant at this point is Well, just delete all the assignments and reset all of them. No. I said other words. I said some words. Let's just say I said words to the helpful tech support. So I've got some classes working fine, some are not. I apologize that Cengage doesn't seem... So I think when I teach this again in the spring, that's what I'm going to end up having to do, but I don't really have the 12 hours to go through and do that right now, unfortunately. So, any questions? Anybody want to go cut cables and play with cables? No? Yes? All right, let's get out of here. Have a great day, guys.